Hi everyone! Today I'm attempting something crazy, which is to break the sound barrier using this 3D printed gearbox. This is an extremely difficult challenge because leading up to those speeds, vibrations, g-forces, and drag forces will be incredibly high. But I'm ready to do whatever it takes, and one thing is guaranteed, either we break the speed of sound or we break the gearbox. What speed do you think we'll reach? Let me know in the comments below. This gearbox was designed to launch propellers over a football field and a half in range. This is possible thanks to its 182 gear ratio and strong construction, which starts with a planetary gearbox to take the input load, which connects to a second planetary gearbox to multiply speed even more. Then, a set of adjustable spur gears multiply speed even more. And finally, bevel gears ensure the rotation axis is away from the user. So let's test this with the three-bladed propeller. We reach a maximum speed of almost 14,000 RPM, and knowing the RPM and diameter of the propeller, we can calculate the speed it's spinning at and convert that into a Mach number, 0.28. So it's clear we need more power. I modified my workbench by making a few holes, installed this custom bracket, and then mounted the gearbox directly to it. I then placed a few weights on the workbench to ensure that it remains stable. So let's go! This increased speed quite a bit, but still not there yet. So I then chose to use this flat disc with the same diameter, which should be able to spin much faster. This provided massive increase, but we still need more. So I then tried a bigger diameter disc. It turns out that this actually did worse. And it's probably due to those crazy vibrations. So I then tried fishing line, which is extremely thin and should provide minimal drag. It also allows me to have a really large diameter, and thankfully I was wearing gloves there. And again, it turns out that it did worse. So it's very clear now that we need more power, and that's why I designed this special adapter. It is designed to use a spade drill bit connected to a power drill to power the launcher. So after swapping out the manual crank for it, it's time to test it. And yeah, that's a fail. So I adapted the design to make it way more bulky and printed it with more layer lines and more infill. So it's time to test again. This time, the adapter survives, and we're actually able to reach a similar speed, but I can see that the drill chokes. So I put it in first gear instead of second gear. And we do reach about the same RPM this time. So it's clear we need, I guess, more power again. So this time I'm using a corded drill, which provides a lot more power than the battery power drill. And you can clearly see it from the footage. But it's not much faster, and that's because the drill is getting limited by the high gear ratio. So I then proceeded to change the pair of spur gears to bring the overall gear ratio much lower. This will allow the drill to spin closer to its max power, increasing the max RPM we can achieve. And speaking of RPM, I want to thank my sponsor PCBWay for supplying the custom PCB required to make the sensor. It was extremely useful in this video thanks to the excellent quality and craftsmanship of the assembled board. They also supply CNC machining, 3D printing, and sheet metal fabrication, which could be useful for any DIY project. So please check them out. So let's go with the adjusted gear ratio attempt. So at the extreme speed this thing was spinning, vibration essentially tore off the disc from the output shaft. And the disc then proceeded to disintegrate itself due to the large g-forces it was experiencing. Looking at the footage again, it's not clear exactly at what RPM the disc broke off from the launcher. So I use a more conservative 22,000 RPM, which still provides a speed of 360 miles per hour. That's a crazy speed, but it's still not Mach 1, and the gearbox, as you can see, is impeccable. So we could actually push this even further. How would you increase the maximum speed we can reach? How else would you break the sound barrier using 3D printing? Please let me know in the comments below. Thanks for watching, please like, hit the bell, and subscribe for more content like this.